All right, we're recording. We're on page 370D in Braille. And on page 470, thanks. 470D in Braille and 470 at the bottom of the page in print. Okay, and so we have a circle K. We have A, C, B on the outside. From C, it's going through our center. There's a diameter. And they messed up on our Braille, and they forgot to put a right angle indicator at that chord. It's in print, but it's not in Braille. So I'm going to tell you that is a perpendicular bisector to the chord, okay? So from where that intersects, they're calling that point D. So at that D intersection, those are right angles, okay? Mm-hmm. From D to B is 7 units. From D to B is 7 units. It kind of runs into the circle a little bit.
Okay.
Got it?
Mm-hmm.
I know. Yeah, it's too small. Yeah. They should have made their tactile bigger.
Yeah.
All right. So from D to B is 7. And the question for this is, it says find each measure in each circle K. And for this one, they want to know AB. So if we know DB is 7, what is AB?
Or no, AB.
Get on A.
AB is 14. That's right. Yep. Because
So
what is AD?
7 to this line. What's from here to here?
Yeah,
13.
7.
7.
AB is a,
7.
Or
Then so the whole line is what?
14 is
14. Don't go that
So
way.
the whole thing is
The
going to be
whole line.
14. Yep.
So from here to here.
Because we got a perpendicular bisector, right?
Yeah.
Okay. So 7 and 7, the whole thing is 14.
14.
All we want to know. That was easy, wasn't it?
Okay.
All right. Now the next one down below, a little more involved, isn't it?
Yeah.
A little more involved. All right. Circle K again. We got a whole bunch of stuff going on up here in the top right corner of our circle K. Yes.
There's no right angle indicator.
They also forgot their right angle indicator on this one. So from K to the point where it says 16 just above it, that is at a right angle
Wait a minute.
to our chord
Okay.
LM.
16.
Well, hold on.
Yeah.
16's on the outside of the circle. Okay. So we got to, this is going to take some extra explanation. So find L at the very top of the circle. So from K to L,
So from K to L.
K to L, and then we have K to about the 2 o'clock position. There's no point there. But what they're doing is that intersection point is a right angle, and they're labeling that N. So from K to N, the intersection of the chord, that is 6. That little leg there from K to N is 6. Okay? Then from K to M, that's just below 3 o'clock. They haven't labeled that. Then outside the circle, they have a funny little like number liney arrow thing, a line, right? And they're labeling that 16. They're letting us know that the chord L to M is 16. Okay? So L to M is 16. So we turn our brains on. We've got a bisector. KN is bisecting. So L to M, as in Mary, is 16. What is L to N? 8. Good. What is N to M? 8. Okay. So we have these 2 right triangles, don't we? And we know the legs. We know one leg is 6 and one leg is 8. So we're going to want to find the hypotenuse, I bet. Yep, KM. We got to find the hypotenuse. So what are we going to do to find the hypotenuse?
Pythagorean Theorem.
Okay, Pythagorean Theorem. So now we have the legs, don't we?
What are the legs?
6 and 8. So we have 6 squared plus 8 squared equals C squared, right? So
That one.
Yeah.
6 squared.
Let me check.
And 8 squared.
64.
So add them together.
All right, what are you getting when you do the work?
I got 100, which is 10 squared. Yeah, I got 15.
You added them together and got 100?
Yeah.
What's the square root of 100? 10. All right, so our hypotenuse there, that km piece, is 10. So again, you know, I'm noticing the math isn't very hard, right? The computation, doing the Pythagorean Theorem, you guys have been doing that forever. But it's that darn drawing, right?
Yeah.
And so this particular drawing, indeed, because it's so small and they were missing a couple of key pieces of information, we definitely want to make sure we advocate and ask and clarify what they're looking for, right?
Mm-hmm.
All right. I'm multitasking or attempting to put together something for, I have these cool little Velcro things to make shapes with, and I'm tearing them apart so that Alex can mess with them. Okay.
We have one of those too.
Make
Velcro.
shapes, Alex?
Mm.
I wonder the younger one's name. And? Yeah, oh yeah. There.
Here's a poster board drawing thing of all the different shapes you can make. Cool? All right. If you want it better, you can play with the abacus.
Maybe only Alex does.
Yeah, Alex knows how to use the abacus. He sure does. All right. Okay, so let's turn the Braille page. Oh, a little better one. Okay, this isn't too bad. Phew, example number 4. A bit of an algebra link, right? Algebra link.
What was that? Example 4.
So
Yeah.
page 471. And we have in circle Q, says, okay, up at the top in circle Q, arc KL is congruent to arc LM. So remember when we learned about if an arc is congruent to an arc, then its chord opposite is congruent to the chord opposite, right?
Mm-hmm.
Okay, so KL is congruent to LM. If CK equals 2x plus 3 and CM equals 4x, we have to find x. All right, so let's go look at our drawing. We have circle Q, big old circle going around this thing. I'm drawing that out. And then from Q, immediately down to 6 o'clock, it goes to point L. And then to the left is point M, and that ran into your circle. And then to the right is point K. So from M to K, there's a chord there. And they said KL, that arc, that minor arc KL, is congruent to the minor arc LM. Okay? And so we know from that original theorem, the beginning of this section, if your arcs are congruent, then your chords are also congruent, right? So we know then that CK, oh, sorry, where the intersection point is C. I didn't tell you that. CK is going to be congruent to CM, isn't it? Because they've been split in half. All right. So they told us CK is 2x plus 3, and they told us that CM is 4x, and we want to find x. So how are we going to find x? What should
Combine like terms?
well,
Or-
let's set it up first. How should we set it up? 2x plus 3 equals 4x is what Jess said. Yes.
Okay.
2x plus 3 equals 4x. Or you could say 4x equals 2x plus 3, right? Doesn't matter. Now we can combine like terms, Stormy, because we've got x's on both sides. We're going to subtract 2x from both sides. So we have 3 equals 4x minus 2x, which is 2x, right? We're going to divide by 2 on both sides, and x equals 3/2 or 1 1/2, right?
Yeah.
Okay.
Remember.
We did it. So the key is that they equal each other, so we're going to make them equal to each other, and then you're going to use basic algebra skills to solve for x. And all they wanted to know was x. They didn't ask for the measure of any of those, did they? They just asked for x. If they would have asked for the measure, we would have plugged it back in, right?
Yeah.
All right, so in the your turn, it says, suppose CK is 5x plus 9, and CM is 6x minus 13. What are we going to do? So down on the your, on the next page on the your turn, it says CK is 5x plus 9, and CM is 6x minus 13. So what do we need to do? Find x. We know they equal each other, right?
Yeah.
So 5x plus 9 equals 6x minus 13. All right?
Yeah. I couldn't find it. Now I found it.
So now again, combine like terms, right?
Mm-hmm.
So subtract 5x from both sides. We're left with an x minus 13 equals 9. Should we add 13 to both sides?
Yep.
Mm-hmm.
All right? And we don't have to do any division. X is just going to equal 22. Done, right?
Yeah.
That's all they wanted to know is just what the x value was. So you're good to go there. Okay? All right? So what do you think about this section? Is okay? Yeah.
Yeah.
The biggest deal is making your way through the drawings. Making your way through those drawings. And if they're not that good, you've got to ask, right? You've got to seek clarity. If you're in college and you've got a weird drawing, ask a peer you're sitting next to. Train them to describe the drawing for you, right?
Mm-hmm.
Ask the instructor if they're available. But usually what's going to happen is you're going to be sitting next to somebody.
Actually, they're really nice.
And you just ask your friends, don't you? Yeah, you just say,
Yeah.
you're like, hey, can you explain this drawing to me? And they will. And you just, just teach them. You got to teach them, right? You got to say, don't say over here and over there. And take this and move it here. But just, tell me like a clock face, or tell me like north, south, east, or west. Right? But for now, you got me and Miss Gardner. We know what we're doing.
Mm-hmm.
But you're not gonna have me and Miss Gardner all forever.
Oh, darn.
No, we can't go to college with you.
Aw.
Aw.
Darn it.
Darn it.
Maybe you'll teach algebra next year.
Algebra 2 is next year. Yeah, I'm not sure if they're going to give me Algebra 2 or not. There's rumor that they're hiring another instructor.
Darn it.
I think I know Miss Lowell is resigning. She's resigning after this year.
Well, we want you.
And I'm here, but they're talking to another a potential instructor. I know of her, and I have very high regard for her. And I'm hoping that she's going to say yes. But I don't want to start the rumor mill, so.
Not really.
But I would don't worry if it's not me. I know that who they're talking to is really good. So in fact, I'd say probably better than me. So.
I don't know about that.
Yeah, no. But I don't know. I have a.
What do you like, JJ?
Yeah. I also have high regard for this individual. So. Miss Lowell's really good also. Yes, very good. But she's going back to school, and she originally got her degree, I think, in marine biology, and she wants to go back and focus in the sciences area again. And so she is following that passion to go back to kind of the sciences. So she gave her notice, and this is her last year here.
Oh, darn.
Ew.
But they're already talking to people, so.
Yeah, good for her.
But I mean, I would also love to teach Algebra 2 for sure. That would be really fun. But I'm also hopefully going to teach a woodshop or one or two woodshop classes, and so that's also a passion of mine. Yeah, we have a really beautiful woodshop that's all closed up and the time warp. I went there yesterday to look at it. It's like the guy that used to teach retired like 10 years ago, and it hasn't really since. Everything's kind of left in its original position, and there's dust all over it. It's really interesting. It's beautiful. But I am a journeyman level cabinet maker, and so I have offered to teach woodshop, so I'm hoping to be able to teach a couple woodshop classes, and one of them would be a math class in the woodshop. Yeah, where you actually use math
Oh, that's work.
hands-on, yeah. So
We could do that online, that'd be cool.
how could we do that? Yeah, we need to talk to Microsoft and Link and get them going. Yep.
That'd be cool.
Yeah. All right. Well, let me turn the recording off because I'm sure Ryan and Tanner and stuff don't need to listen to us banter here.